Hello, wonderful, amazing, fantastic algebra students. This is Miss Youngblood here, bringing you another content video for algebra. So let's jump on to Google Classroom and see what we'll be learning today. On Google Classroom, I'm looking at the May 25th through 29th content. The topic for this week was quadratic equations. And for our second session, we were talking about solving quadratics. So the first session is already up. I have the video and the notes for those who still need assistance with it. Now we're looking at the second session, which is about solving quadratics. So we're going to launch Khan Academy. Again, if your page does not take you straight here and you are not automatically signed in, please make sure you take the time to sign in with whatever email you use to sign up for my Khan Academy class so that I can monitor your progress and give you your points for the work you're doing. So in this session, we're going to be looking at, starting with this first assignment, solving quadratics by factoring intro. 4 problems, let's go, let's get it. So this is our first problem. In this problem, we're asked to solve for x, and they ask us to write the smaller solution first and the larger solution second. This is very similar to what we were doing in the previous session, where we were solving quadratic equations using the zero product property. So I'm going to copy this over to my sketch pad, give you a quick refresher of how we're going to do that, and then we'll start working on this one. So in my sketch pad, I've gone ahead and added the first problem from my Khan Academy problem set, and I've also added an example that we're going to review together to kind of see how we can solve this. So this is what we talked about in our last session, solving equations that look like this. By the zero product property, that means that in order for this whole thing to equal 0, either our first factor, x minus 2, has to equal 0, or our second factor, x plus 3, has to equal 0. So one of these must be true in order for this whole thing to equal 0. In order to solve those equations, we know we would add 2 to both sides for the first one to get an answer of x equals 2. And subtract 3 from both sides for the second one to get an answer of x equals negative 3. So these are the two x values that when we plug them in, they will make this whole thing equal 0. So if this is 2, this is 0 times 5, 0 times 5 is 0. This is negative 3, this would be negative 5 times 0. And negative 5 times 0 is 0 as well. So we want to get our given problem to look like this. And the way we do that is by using our box method. So we're going to use the box method to factor this expression and get it to look like this. Let's go ahead and draw our boxes. So we have our box. When we're filling them in, we know the x squared goes in the upper left box. The 27 goes in the bottom right. And we have to break up this negative 12x between these two boxes. So we're looking for two numbers that are going to add to get us negative 12, but we want them to multiply to equal 27. And again, that comes from this diagonal. 27 times 1 is 27. So two numbers that multiply to 27 and add to negative 12. In my head, I've already thought about 9 and 3. So I know 9 times 3 is 27, but 9 plus 3 is not negative 12. But if I make them both negative, negative 9 times negative 3 is positive 27, and negative 9 plus negative 3 is negative 12. So we're going to break up this negative 12x into negative 9x minus 3x. Okay, so now we can go ahead and factor this. So we're going to have x's here, right? X times x is x squared. X times negative 3 is negative 3x. And x times negative 9 is negative 9x. And to check it, we can see negative 9 times negative 3 is positive 27. So we factored our expression to x minus 3 times x minus 9 equals 0. So now we're going to solve it just like we solved this one. Let me just mark that this is an example. Okay, so now we're solving this the same way. X minus 3 equals 0. x minus 9 equals 0. Adding 3 to both sides gets us x equals 3 for one answer. Adding 9 to both sides gets us x equals 9 for our other answer. So this would be our smaller answer. So you would type that in the box for the smaller answer in Khan Academy. This is the next problem in our Khan Academy set. X squared minus 12x plus 6 equals 0. For this problem, again, you want to start by drawing your boxes. So now we need to fill in what we know. So we have x squared, we have 36, and we're trying to break up this negative 12x between these two boxes. So we're looking for two numbers that will still add to that negative 12, but will multiply to get us 36. And again, that 36 comes from 1 times 36, the diagonal. Okay, so if I'm thinking of my factors of 36, automatically I think of 6 and 6. 6 times 6 is positive 36, but 6 plus 6 is not negative 12. If you make them both negative, negative 6 times negative 6 is positive 36. Negative 6 plus negative 6 is negative 12. So we're going to break up that negative 12x into negative 6x and negative 6x. Continuing to fill out the rest of the box, the outside, we have these two x's. We have negative 6 here. X times x is x squared. Negative 6 times x is negative 6. And again, negative 6 times x is negative 6x, and negative 6 times negative 6 is positive 36. So we have factored this expression to x minus 6 times x minus 6 equals 0. To solve it, we have two of the same factors, so we just need to solve one of them. X minus 6 equals 0. Again, if you want to write it twice, you can, but you're going to get the same answer, so you do not have to. We're going to add 6 to both sides. So that gives us the final answer of x equals 6. So for this problem, you only have one blank to fill in, and you would just type in 6. All right, next problem, we're going to be solving x squared plus 9x plus 18 equals 0. We're going to start this problem the same way. Draw your boxes. So we have our boxes here to help us factor this expression. So x squared is in the upper left, 18 is in the bottom right, and we need to split up this 9x between these two boxes. So we're looking for two numbers that will add and still equal that 9, but will multiply to get 18. And that comes from the diagonal. So our two numbers that multiply to 18 and add to 9 are 6 and 3. Just to verify, 6 times 3 is 18, 6 plus 3 is 9. So we get 6x and 3x. Again, these two boxes or terms add to equal 9x and multiply to equal 18. So now we're factoring x and x. So x times x is x squared. X times 6 is 6x. X times 3 is 3x. 3 times 6 is 18. So we factored our expression to x plus 3 times x plus 6 equals 0. Now we're going to set both these equations equal to 0 and solve. So we have x plus 3 equals 0 and x plus 6 equals 0. So we're going to subtract 3 from both sides to get x equals negative 3. And we're going to subtract 6 from both sides to get x equals negative 6. So these are our two answers. And our smaller answer would be negative 6. And that's because that number is further away further to the left on the number line. So that's why negative 6 is the smaller answer. This is our next problem in the set. We have x squared plus 12x plus 27. and I forgot to copy the equal 0, so I just wrote it, and now we're solving this the same way. Start by drawing your boxes, fill in the x squared term and the 27 term, and we need to break up this 12 between these two boxes. Did they give me? Oh, they gave me a very similar problem here, so there's going to be one little change we make. So we need two numbers that are going to add to equal 12, but multiply to 27. So 9 and 3. 9 times 3 is 27. 9 plus 3 is 12. So we have 9x and 3x. Okay, so now we're figuring out the outside. X times x is x squared. X times 3 is 3x. X times 9 is 9x. 9 times 3 is 27. So we have factored this expression to x plus 9 times x plus 3, and that's still equal to 0. To solve this equation now, we set both factors equal to 0 like we've been doing. So we have x plus 9 equals 0, x plus 3 equals 0. Subtract 9 from both sides for our first equation to get x equals -9 for our first answer. Subtract 3 from both sides for our second equation to get x equals -3 for our second answer. In this one, the -9 will be the smaller answer because it is further to the left from the number line. So that can, oh, let me go ahead and type that in because that's our last problem. So let's type that in. So we're going to have -9 and -3. Nice. That's our last problem for that first set. Done. Yay. And that concludes this set. The next set we have to do for this session is quadratics by factoring. That's the last assignment. And that's actually going to be your last math assignment for the school year. The rest of the school year will be SEL, Google Forms, telling you how you're doing, your plan for the summer, easy stuff like that. So this will be your last math assignment. So if you made it this far, congratulations, you're done. Let's go jump into this one. So we're basically doing the same thing, but we have to start by factoring out a greatest common factor first, because these numbers are kind of big. So if we can find some number that we can divide each term by evenly, the greatest common factor, that will make our numbers easier to deal with. So we're going to copy this over to our sketch pad and work it out. We've gone ahead and copied our first problem from this new set into our sketch pad. So we have 2x squared minus 28x plus 98 equals 0. And for this problem, we want to start by factoring out the greatest common factor. We want to find the biggest number that we can divide 2, 28, and 98 by. So let's see if we can find that number. So we want to start with the smallest number we see, 2. And usually for these assignments, that's going to work. So the smallest number we see is 2. If we divide our first term by 2, we are left with x squared. If you divide the second term by 2, you're left with -14x. Divide the third term by 2, you are left with 49. All I did was just do that division in my head, but of course you can use your calculator as well to get those answers. And that's still equal to 0. So now, pardon me, we're doing the exact same thing we're doing up here. Jump straight into your boxes. So we have our boxes. X squared, upper left, 49, lower right, breaking up this -14. So I do want to emphasize, I didn't really emphasize this, we're now working with this expression. So we've broken down these smaller numbers, we factored out 2, so now to factor this expression further, we're using the box method. So that's where the 49 came from. And now we're looking for two numbers that are going to add to equal that -14. but multiply to equal that 49. 1 times 49 comes from the diagonal. So those two numbers are going to be 7. Let's verify. 7 times 7 is 49. 7 plus 7 is negative 14. So we have to make them both negative. Negative 7 times negative 7 is positive 49. Negative 7 plus negative 7 is negative 14. So we're going to break up that negative 14x into negative 7x plus negative 7x. And now we have all we need to factor the outside. So we have x times x gets us x squared. X times negative 7 gets us negative 7x. X times negative 7 again gets us this negative 7x. And negative 7 times negative 7 is 49. So we have factored this part of the equation into x minus 7 times x minus 7. This part of the equation still needs to come down. It doesn't affect your answer, so it's not really going to affect your work for my class. But when you get to a class like Algebra 2, you might be asked to just factor an expression completely. And when you're asked to do something like that, you have to make sure you bring down this 2 as well. So we're going to bring down this 2, and this equals 0. So I just want to emphasize that this thing that we just created down here is still equal to this. We just divided everything by 2 and factored this into x minus 7 times x minus 7. So if we multiply all of this back, we will still get 2x squared minus 28x plus 98. The reason we're putting it in this form is because it's easier to solve the equation that way. So to solve the equation and finish the problem, we're just going to have x minus 7 equals 0. Add 7 to both sides. So our final answer is going to be x equals 7. Again, I only wrote it one time because I would have the same equation twice. So that's why our answer is x equals 7. For our next problem in the set, we're going to be solving 5x squared plus 15x minus 50. So again, we want to start by factoring out the greatest common factor. The smallest number we see is 5, and we can divide all of these terms by 5. So we'd be left with x squared plus 3x, right? 5 divided by 5 is 1x squared, 15 divided by 5 is 3x, negative 50 divided by 5 is negative 10. So you get 5 times, ahead of myself. So now we need to go ahead and use our boxes to factor this remaining expression on the inside. So set up your boxes for the box method. So we're going to be left with x squared in the upper left, negative 10 in the bottom right, and we're breaking this 3x up between these two boxes. So we're looking for two terms that will add to still give us that 3, but multiply to negative 10, and that negative 10 just came from doing 1 times negative 10 in those boxes. So in my head, I've already thought of 5 and 2, right? But I know one of them has to be negative. So if I make the 2 negative, let's see if that works. 5 times negative 2 is negative 10. 5 plus negative 2 is 3. If that didn't work, I would just move the negative sign to the 5, but it happened to work. So we're going to break it up into 5x minus 2x. So right now we've broken up that 3x into 5x minus 2x. And now we're writing the factors. X times x is x squared. X times 5 is 5x. X times negative 2 is negative 2x. And negative 2 times 5 is negative 10. So now we have factored this part of the expression. But let's rewrite this whole thing. So we have 5, parentheses, x plus 5, parentheses, x minus 2, equals 0. To solve this as we've been doing, set both factors equal to 0. X plus 5 equals 0. X minus 2 equals 0. Subtract 5 on both sides. Add 2 on both sides. So x is negative 5 is going to be one answer. X equals 2 is our other answer. And our smaller answer is going to be the -5. The next problem is 4x squared plus 4x minus 168. Started the exact same way by factoring out the greatest common factor. So look at that smallest number in the front. Again, for right now, that's going to be our greatest common factor. 4x squared divided by 4 gets us x squared. 4x divided by 4 gets us x. And 168 divided by 4. Let me do that in my head since I'm on camera. So 168 divided by 2 is going to be 84. 84 divided by 2 is going to be 42. So I'm going to say it's 42. I'm not 100% sure about that, so I'm going to check it real quick in my head. 4 times 40 is 160. 4 times 2 is 8. 160 plus 8 is 168. So I did it right. So now we're going to jump, don't forget that equals 0. And now we're going to jump into our boxes. So draw your boxes. Start. So now we're going to put x squared in the upper left, -42 bottom right. Break up this x, or this 1x. So we're going to look for two numbers that will add to equal 1 and multiply to -42. And that -42 came from multiplying this diagonal. In my head, I've already thought of 6 and 7. Let's make the cellular negative and see if that works. So 6 times -7 is -42. 6 plus -7 is -1. So since that doesn't work, let's try making the 6 negative. Again, -6 times 7 is -42, and -6 plus 7 is 1. So again, you just have to play with the numbers. The easiest way to eliminate possibilities is by first figuring out if the factors can even add or subtract to this value. So like I immediately knew 1 and 42 wasn't going to work because I cannot add or subtract those to get 1. I immediately knew 2 times 21 was not going to work because I cannot add or subtract those to get 1. So you really just have to be familiar with the factors and be willing to sit and play with the numbers. So we're splitting that 1x into -6x and 7x. So now we can factor x times x is x squared. X times -6 is -6x. X times 7 is 7x. And 7 times -6 is -42. So now we can rewrite our problem. So we now have 4 times x plus 7 times x minus 6 equals 0. Now all we've done is figured out what was multiplied to get this. So we've undone the distribution that happened here. So now to solve this equation, we're going to have x plus 7 equals 0 and x minus 6 equals 0. For the first equation, subtract 7 from both sides. So your final answer is x is -7. In the second equation, add 6 to both sides. Final answer is x equals 6. Smaller answer is going to be the -7 because it's further to the left on the number line. And this is our last problem, our last algebra math problem for the school year. Yay! So we have 2x squared minus 40x plus 200. Start it the same way we've been doing it. Greatest common factor. In our case, since we're just getting started, it's just going to be the number in front. So it's 2. If you divide the first term by 2, 2x squared divided by 2 is x squared. -40x divided by 2 is -20x. And 200 divided by 2 is +100 equals 0. So we factored out our greatest common factor. Now we're going to factor this expression more by using the box method. Draw your bestie. We would not have made it this far without our bestie boxing. So we have bestie boxy here. We're going to fill in the upper left box with x squared, bottom right box with 100. And now we're going to break up this negative 20 between these two remaining boxes. So we have, we're looking for two numbers. You can see the light. Looking for two numbers that add to equal negative 20, that are going to multiply to equal 100, and that 100 came from this diagonal. The reason I keep showing you this 1 times 100, and I don't want you to just think it comes from here, is because when you get to Algebra 2, you're going to get polynomials where even if you factor something out, there might still be a number here like 4 or 7. So if there's a number here, in our case it's been 1, but if there was a different number, you would have to multiply these two numbers to get this number here that we're focusing on. That's the reason I keep doing it. But for us right now, it really doesn't matter. It looks like it's just this number. So we're looking for two numbers that multiply to 100 and add to negative 20. So I'm going to try 10 and 10. 10 times 10 is 100. However, 10 plus 10 is not negative 20. Since I know it has to multiply to a positive number, let me see if two negatives will help me. So negative 10 plus negative 10 is, negative 10 times negative 10 is 100. Negative 10 plus negative 10 is negative 20. So that we're going to split up this negative 20x into negative 10x and negative 10x. Factor it out, put these x's here. X times x is x squared. X times negative 10 is negative 10x. X times negative 10 is negative 10x again. Negative 10 times negative 10 is 100. That's just our check step. So now we factored this further. So let's rewrite what we got now. So that 2 is still in the front, but we factored x squared minus 20x plus 100 to x minus 10 times x minus 10. And we still have that equals 0. Now this equation has been written in a new way. This was the original. It's still equal to this, but we've rewritten it in a way so that it's easier to solve for x. To solve for x, we just have to set our factors equal to 0. So x minus 10 equals 0. The other factor is exactly the same, so there is no need to write it. So we're going to add 10 to both sides. So x equals 10 is our final answer. So let's switch back to our browser. Oops, close that on my lines here. Is it showing now? Let's see. Now I can't find my mouse. We're doing so well, young people, weren't we? It was fun while it lasted. Okay, here it is. Okay, so you can see it. Great. So in our browser, the answer? Yes. No. Positive 10. X equals positive 10. X equals positive 10. Yay, we did it. We just completed our last problem for algebra. It's math problem. I still want to ask some lovey-dovey questions to see how you're doing. So at this point, all these should be done. So yeah, that concludes our last session. Since this is my last video recording content, I just really want to emphasize, you can still go back, click on past, and you can still complete all of the missing or incomplete or low score Khan Academy problem sets that you have. So you can go back, anything that's late, it's still here. Just click start and work on that, and I will update that grade for you in PowerSchool. There is still time. You have until Monday, June 8th at 11:59 p.m. I'm not taking anything June 9th, midnight after that, okay? So please get it in. Ask for help if you need it. I'll be posting videos and notes here to help you. Next week will be an SEL week, so you'll have easy Google Forms to fill out that will still help your grade. And yeah, so I just want to, again, emphasize, make sure you're following the schedule, 2 classes a day, checking in with your teachers, bare minimum if you're not going to class. I do want to say that I appreciate those who have been consistently coming to Zoom. I feel like I'm one of the few teachers who consistently gets at least one kid in her class, so I appreciate those few kids who are coming. You make my job feel worthwhile. And those who haven't and have been working on Khan Academy, I appreciate you too, because you're still getting your work done. So yeah, just emphasizing the last day to turn in everything is Monday, June 8th, 11:59 p.m. We're still gonna have our regular class schedules next week, but you can come to any of the hours. You can come to my 1A, 2A, 3A, whatever. As long as I, send that little post in Google Classroom when I tell you I'm about to get on Zoom. So I think that pretty much covers everything. If I missed anything and if you have any questions, please do not hesitate to reach out. As always, you can text me, you can email me, or you can just come to office hours in Zoom. I hope you found this video helpful, but if you didn't, continue to reach out and I will help you. Thank you so much for taking the time to watch this video, and I look forward to seeing or hearing from you soon. Bye.